Okay, now we can start. Great. So, my name is KRISTIAN Salo. I come from SimpliVity. A little bit about my background. I came from EMC, where I was responsible for disaster recovery, backups and replication and archiving and stuff like that. I worked there for about 8 years, little more than 8 years. Before that, I was working for Sun Microsystems for 5 years. Spark, Solaris, data center stuff, and before that I worked for IBM in the AIX printing area, which was quite interesting. And so now I have been working about half a year at SimpliVity, and what is this SimpliVity? During this presentation we'll have a short glimpse of the SimpliVity as a company, where we come from, and what do we do, and what is this hyper-converged architecture that most of the IT industry is talking about. So we'll get a glimpse into that one also, and in the end I will show some other stuff in the demo, how we can clone, move, virtual machine and stuff like that, how we make things more simple. As I said earlier, there will be also in the session 3 a technical version of this same presentation, but it is an extremely simple solution. So I had a big challenge of how to make a technical and business version of this simple area, but there will be more technical stuff in the other area. So where do we come from? So SimpliVity was founded in 2009 and by a person called Doron Kempel, who in the early 2000s founded a company called Diligent. And Diligent was a company which made deduplicating appliances for backup usage. And Doron Kempel sold that company to IBM, I think it was 2004 or 2005. And with that money, he started a new company, SimpliVity, with some industry veterans from EMC, NetApp, VMware, Oracle, Dell, etc. And those engineers that he worked with started to work with the mission of simplifying the IT, simplifying the way how we do a data center, a virtualized data center. So at the moment, so we were founded in 2009. We spent 3.5 years in what we call a stealth mode. So the product was developed for 3.5 years, which is in a startup world, it's a long time. Usually when you have can you hear me still? Okay. Usually when you have an investor that invests into a startup company, they say that, okay, you have to have a real product in 12 to 18 months. So, but because Doron Kempel had some money from the Diligent deal, they were able to make the product really ready for the production and ready for critical environments. So we came out with the product 2012, and in the VMworld 2013 we received the Gold Award for Best Storage and Backup for Virtualized Environments, which is just only few of the functionalities or features of the Omnicube stack. So backup and storage, it does a lot of other things also. So in these awards, I think the coolest award is the Best Converged Infrastructure Product winner that we won on the same year, and then some other awards. But even more important than any awards, I think that we have really interesting customer references. Some Europeans, like T-Systems, are running cloud kind of their virtualized environments on Omnicubes. And as a technical guy, I find this Petrobras really interesting. Petrobras is one of the top 5 oil companies in the world, a Brazilian big oil company. And what they do is that they have these drilling platforms somewhere in Caribbean Ocean, and then they have these huge boats that go to these drilling platforms to get the oil. And the problem was in the previous, in their earlier data center, was that there was a VMware cluster in each of these ships gathering all the information, all the testing data and from those oils and tests, etc. Very important information for the company. and they did not have any like real backups. They had backups inside that chip, but if something happens to that chip, they would lose millions and millions of money because if they lose that important information. So what they do with Omnicubes is that they build a full high available VMware data center with 2 Omnicubes, 4 rack units, which are backing up over a satellite, 2 megabit satellite link to a Texas data center, full daily virtual machine backups. And those of you who were here before I started this presentation saw how fast the recoveries are. 5 terabyte virtual machine recovery, about 10 seconds. So there is some magic happening underneath the hood, the way we do things. So that's technically a really nice reference. This is also a very good one. There are some towns in US that are using Omnicubes as a platform for 911 systems, like when you call police. So those systems are running on top of Omnicube. So in a really, really critical environment. And some other references. We have some non-public ones in the Baltics and Finland also, and some that we can talk about if you come to our little booth just out of that door. So let's start to talk about what was the kind of technical issue that this group of engineers started to work on in 2009. So there was this Doron Kempel's team who started to think about what is the kind of underlying problem, the core problem in the data centers, the way we do them today. And they came with this kind of idea or thought of what they call a data problem. And it comes from a very, very common fact that probably even today most of the presentations had a slide that we have more data every year. So we all know that. But why is this a problem when you build data centers? One of the underlying issues of all this data growth is the I/O. How we can move all this data around between the different layers in your virtualized data center. And the I/O problems come also from the fact that, let's think about disks, the spinning disk that you have in your data center. And think about the disks that we had 10 years ago. We had 36 gigabyte disks about in your storage systems. And the IOPS that you got from a one disk was about 180. Today, we have disks, 3, 4, even 6 terabyte disks. And from one disk, you get about 180 IOPSes. Actually, you get even less in those big disks. So we have a situation where we have a lot of more capacity, but we did not get a lot more performance. And I have, in many times, I have used an analogy. Like 10 years ago with your 36 gigabyte disks, you had a drinking straw and you were drinking from a glass. And now you have a drinking straw and you are drinking from a swimming pool. So it's starting to be a problem. So on top of the I/O gap that we have in storage, which is just one of the layers in your data center, we have some other features and functionalities that your data center must provide for your virtual environment. You have performance, of course. You have to get the IOPSes out of the system for those applications to run as fast as they are needed. You have protection. You have heard probably really cool stuff today about security, but protection also for the data, meaning that you have to have a way how to recover virtual machines really fast so that your business can continue. Those days where you could back up to tape and then recover few weeks are gone. So when I was working for EMC, I heard stories where companies had a really fine-tuned backup system backing up to tape with several media servers, highly multiplexed streams going to these very fast tape drives. So their backups were going really fast and efficiently. And then they lost the storage. the production storage. The IT guy was like, yeah, I have backups. I have done my backups. They are going really fast. But when they started to recover, they noticed that, okay, I have my backups, but it takes 2 months to recover everything because it was a big company. And you can guess what happens to a company if they are out of business for 2 months waiting for the recoveries. They go belly up. So this is actually a kind of a true story that happened to a company. They had really, really nice backups, but they couldn't recover in time, so they couldn't continue their business. So you have to have a protection for your data in a way that you can do extremely fast recoveries to keep your business going strong. With mobility, I'm not talking about mobile phones. I'm talking about mobility of the virtual machines, meaning that how you can move virtual machines for security, for disaster recovery, and also for test and development. Let's say that I have a VMware cluster with my production, and I want to test something. There needs to be a way how you can clone and move that virtual machine easily without bothering your production environment and do tests somewhere else. Things like that. With capacity, that's of course, you have to have the capacity to work with this one. And management, in many cases, management is starting to be really, really complicated. And also that is a security threat. Because how many of you have seen desks like this, where there is an administrator who is trying to work with servers and network and storage and one acceleration and VMware and the backup application, etc. So there is I am a tech geek. I'm a nerd. I love this. It's cool to have many monitors, but to run an efficient IT, it's not a good idea to have this much of complexity in your data center. Because more you have different kinds of things there, more you have areas for error. So let's have a look how we have gotten into this situation where we are now. So we started years back in a situation where an application running on an operating system had its own resources. It had storage, it had CPUs, and it had memory. But the problem with dedicated physical servers was, of course, that if this storage started to be full, there was no way of getting these loaned or shared to the other way. So then came companies like EMC, NetApp, HDS, whatever, with this great idea of let's consolidate storage. Let's make a centralized consolidated storage and have this pool of storage that I can give to these servers as much as they need. Few years later came companies like VMware and the other virtualization companies, and with the kind of the same idea but for CPU and memory resources. Let's put a hypervisor on top of a physical server and run our servers as virtualized servers. So now I have a pool of CPUs, pool of memory, and pool of storage that I'm using. Great idea, and worked really, really nice. Some customers, of course, because this is critical environment, they wanted to replicate everything to 2 sites. Just to be clear, if something happens to my production, I have a secondary site where I can run those. Again, really simple, really easy to operate when you have a little bit of data. But let's throw the data problem on top of this. When you start to have 10 terabytes, 50 terabytes, 100 terabytes, and even petabytes of storage, it starts to be, you start to generate different problems in different areas of this stack. Let's start from the bottom. If I have few gigabytes, it's easy to replicate that there. But when I start to talk about tens of terabytes, you have to have either a huge pipe between these or some other solution. So when you throw the data problem on top of this picture, that actually has generated or gave birth to companies of solving point problems here, like this replication. Okay, I have a problem of getting a lot of data there. Let's build these great appliances for one optimizations. Well, you all know what one optimization boxes do. They are really, really nice systems of solving this specific problem. How to get a lot of data over a thin line to the other side, so I have my data safe there. What about backups? As I said, the problem with tape, let's say I have 10 terabytes of production data. How much, if I want to have a 6-month backup rotation, it would mean that I have 4 full backups for weeklies, week 1, 2, 3, 4, increments between there, and then I have 5 fulls for the monthlies. So now I have 90 terabytes of tape from my 10 terabytes of production storage. If I have 100 terabytes of production storage, I have petabyte of tape. So again, some companies were born to fix this specific problem, the deduplicated backup appliances like Data Domain, Quantum, etc. Really, really great products of solving this specific problem. Again, some customers, for some reason, want to put backups to public cloud. Some do, believe me, for some reason. but that gave birth to these cloud gateways. Then we have the I/O problem, how to get performance out of these, because if I have a lot of data, I need to get IOPSes, and the one way of getting IOPSes is to put SSD, like dedicated SSD arrays, or SSD cache, so you put hot data there and colder data lives on these big capacity disks. And some companies decided that it is a really, really good idea to put the SSD near the actual CPUs and memory to get the best performance, so these I/O cards were born, SSD like Fusion I/O and stuff. Really, really great products to solve that problem. And of course you can get SSD in your disk also. And you need the backup software, etc. So something that was really, really simple is not that simple anymore. And this is something like, okay, most of you who have worked with data centers think this is normal. But trust me, this is like that if you have had a knee pain in the knee for 15 years, it's okay for you. You're used to it. Okay, this is the normal. But it's not. This is starting to be a really, really pain in the system, and how to fix this. So the problem is here that if you look at the kind of a normal way of building these systems today, you have the servers, you have storage, you have storage switches, you have storage, high available storage, maybe SSD backup appliances, a huge stack of stuff in your rack. And the problem is that all of these have different kinds of management user interfaces. I have different kinds of for my servers, I have different for my storage switches, I have different for my storage, different user right. Well, you get the picture. So I have too many boxes, screens, too many IOPSes, refresh. The refresh cycles, that really sucks. So I have been in many data centers where let's say that you update your storage. You have to figure out that does your new storage, is the compatibility matrix okay with your HBA cards? And if it is the HBA cards compatibility matrix okay with your tape drive, etc. So you have these huge compatibility matrices to figure out every time you touch that stack. So that's this problem. Too much data to manage, etc., etc. So this is a known problem in the IT industry. And IT industry is trying different ways of fixing this to make it more simple. And about 4 or 5 years ago, the IT industry started to talk about these, what they called converged infrastructure, or converged, difficult word to pronounce. but they started to talk about converged infrastructure, and the idea there was that if this is your legacy stack, where the organization builds these themselves, using servers from, let's say, Dell and switches from, well, somewhere else, and storage from somebody, and etc., etc., and integrates themselves all of this. The kind of first generation of converged infrastructure was these integrated systems. When companies like VMware, Cisco, and NetApp came with the FlexPod, when companies like EMC, VMware, and Cisco came with the vPlex systems. Really, really great idea of integrating this, the servers and the storage, into this kind of a pre-integrated package. You have small, medium, and large one, big one. So it made the implementation of this a lot easier. But the problem here is that they basically left a lot of the functionalities that you need in the data center, like the backups, the disaster recovery, the remote replication, stuff like that, out of it. I remember I was working with EMC when they came with the, those vPlex systems. It took about 2 years to come out with a white paper how to back up that thing. So great idea, but there's room for improvement, let's say it like that. So the next generation of converged infrastructure is kind of what we call a partial converged, or converged 2.0. And this is actually how companies like Facebook, Amazon, Google are doing their data centers. They are using x86 servers with internal disks, SSD and spinning disks, and use those x86 internal disks to build a virtual storage. So more you add those boxes, more you get this virtual storage, so you don't actually need dedicated centralized storage anymore. To have this really, really simple way, if you need more something, you just add these x86 building blocks into that. And this is an awesome way of building stuff. That's why the Googles and the Facebooks and the Amazons, they can scale like whoosh. But again, if I want to run a typical data center where I need to back up application data, where I want to do fast recoveries and stuff like that, you're still missing a lot of the functionalities. And so what Omnicube does is that we build the whole functionality of the whole stack. Start the servers, the storage, the WAN optimization, the backups, the recoveries, disaster recovery, and data optimization. And what I mean with that, I'll talk more in the technical session, but I'll give you a glimpse of it. And we bring all these functionalities in this basic x86-based building block. So if you need all these capabilities, you just, and if you need more scalability, you just add more of these boxes. So I have what they called a low-cost commodity x86 approach, but with the enterprise capabilities. Meaning data protection, data efficiency, performance, global unified management, one user interface for all these functionalities. And that one user interface, some of you already saw it when I was testing my demo. It's the vCenter plugin that the VMware, the same vCenter the VMware guys are using anyways. One user interface, really, really simple. So kind of easy way of understanding what this means. Well, at least as a geek, I used to have all these different kinds of boxes. Now I have my phone. So let's go back to this picture where we had the typical way of building this data center, and think about what Omnicube brings here. So what Omnicube brings here is, because one of the features of Omnicube, and now comes a lot of hype words behind, in a row, one of the features of Omnicube is that it is an inline deduplicating scale-out storage. That sounds cool, but what does it actually mean? Inline deduplicating means that all the data that are written from the virtual machines to the Omnicube storage is deduplicated, compressed, and optimized inline, almost wire speed. So everything gets deduplicated and compressed when it gets into the Omnicubes. And there's a huge benefit in that. I will explain that in just a few moments why. And scale out means that if you need more capacity, you just add more Omnicubes. One box comes with about 20 terabytes of capacity. If you need more, 2, 3, 4, etc., etc. So one of the functions, as I said, is it is an inline deduplicating scale-out storage. So you don't need these dedicated storage systems anymore. Easy. Because we deduplicate and compress everything, so virtual machine actually is metadata pointing to a pool of deduplicated blocks, which means the virtual machines are really, really light, so we can replicate, backup, clone, and move them really easily because we are actually moving just the metadata and using the blocks in the destination for the actual data. This is the concept that I will explain more thoroughly in the technical session, how that works. But so when I want to do a backup of a virtual machine from here, we actually send the metadata there and use the blocks that are over there. So the moves between data centers happens in seconds. So I don't need WAN optimization for that. That's a built-in feature. Backup is a built-in feature. Everything gets deduplicated and compressed into the system, so we can use those same deduplicated blocks for backup. I don't have to re-deduplicate them for backup. So I don't need a backup applications also. Cloud Gateway is a feature in the stack. So we have an integration to the Amazon cloud. So if you want to put your backups into the Amazon, we can do that. And in the demo, I will show how I recover a 70 gigabyte virtual machine from the Amazon cloud, 1 megabit line, about 10 seconds. We have SSD in there, so we get the performance. Out of one box, you get about 20 to 35,000 IOPSes. If you need more performance, you just put more Omnicubes. It's a scale-out system. And there's actually a white paper in our booth where we show how to, by adding Omnicubes, you get a linear scalability where we go over 1 million IOPSes. And because it is a scale-out system, so you put more, and on top of the Omnicubes, it's running the ESXi binary, so you don't need ESX hosts. The VMwares are actually running on top of the Omnicubes. All the functionality of the classic stack is built into the Omnicube stack, and you run your virtual machines on top of that. So the way of building data center just got really, really simple. If you give me the IP addresses, I can build a full VMware 2-site data center with remote replication, backups, policies, and everything in about 1 day, half a day if all the firewalls and everything is open. So it's really, really fast and simple. When do I need to stop? Okay, thanks. So, as a recap, simplify your IT with hyper-converged infrastructure. The Omnicube, it's a hyper-converged architecture. It has the data virtualization platform, the deduplication, compression, and optimization. I will explain thoroughly in the technical session after the break in the other room how does that work. So if you're interested, come there. And it has the global unified management with the vCenter plugin that I am going to use in the demo that I'm going to show you in the last 5 minutes that I have. Just a second. And now let's hope that I have still my network. I do. Great. So, can you all see it? Hopefully. Here I have a 5 terabyte virtual machine. Let's say that this is my production system. I want to do a full clone of that machine. I'll go here and I'll do a clone. And you can see in the task window, usually, is there a VMware admin in the room? How long a normal VMware clone happens for a 5 terabyte machine? Normally. Long time. We are ready. Was that a long time? No. Yeah, I agree. So that was really, really fast. So we can do stuff that is impossible in the normal data centers. So I have this virtual machine here. Let's take this virtual machine and I'll move it to another data center. I'll take this and I'll move the virtual machine between the data centers from Boston data center to another cluster in the San Jose data center. And I'll start the move. It is a 5 terabyte virtual machine between 2 data centers and data stores. While it is moving, that will take not a very long time, but it will take a few moments. You will see it is here, and usually when it goes to 45% here, it has been moved to the other side. But when that is going on, I'll go and do a recovery from my Windows machine. Now you saw that. Okay, I'll show that to you now. So my 5 terabyte virtual machine that was here, it's actually now here. So the move is completed. And this is something that one of our customers said that it took them 5 days to do. We went from 5 days to 30 seconds with them. So let's do a recovery from the Amazon cloud as I promised. So I have here, I have here a 70 gigabyte virtual machine. You can see it here. I have all my backups are listed. Let me find. It's a bit slow connection with for my mouse or for the user interface, because the actual demo system is in. Okay, here I have it. Here I have all my backups. As you can probably see, it's a little small resolution, so but you can see that it is backed up to Amazon. And I want to do a full recovery of this 72 gigabyte virtual machine into the Boston cluster. So it is in Amazon East, and this really is in Amazon. There's a 1 megabit line from our test demo center to the Amazon. And I choose where I want to put it, into the Boston data center, and I'll do a full restore. I say yes, and you can check from here in the task window when the recovery starts. It's starting, it's ready now, and now it gets registered here. Oh, it's already there, or is it? Yeah. Yeah, that's the one that we recovered. So I can go to the summary, take a look that it is 72 gigabytes. I just recovered from the Amazon 72 gigabyte virtual machine. I can start it for you. So let's go to the edit set. I just want to take the network card off because it would otherwise start on the same IP. Sorry. So, and now I have this on. I'll go to the power on, and I'll go to the console to see that it's starting. Yeah. Full 72 gigabyte virtual machine from the Amazon cloud started in less than 1 minute. Cool stuff. In the technical session, I will explain how that happens, what we do. But unfortunately, in 35 minutes, I cannot tell you everything here. If you are interested, Keijo, could you, Keijo, stand up? Keijo is my sales guy. So that way with the orders. No. But okay, but just to talk, we are the guys with the blue shirts. If you need to talk and ask, we will be here the whole evening. So if you have questions, if you want the white papers out of the door, right on the left side. Just take all the white papers and some cool pens from there. And the technical session starts in the other room after the break. Okay, thank you for your